Hey everyone, we talked about the features of the moon, the impact craters that we see, the Maria, but now we want to talk about how much of the moon we see. And this picture shows you that at different times of the month, we can definitely see different parts of the moon.
It looks like it gets bigger, it looks like it gets smaller. It doesn't actually get bigger and smaller. We actually have something called phases.
And so phases really come from not anything with shadows. There are no shadows from the Earth going onto the moon yet. But what we're talking about in phases is how much of the moon we see based on the angle that the Earth, Sun, and Moon kind of make up.
Right, we get illumination based on its position with regard to the Earth and the Sun.
So some of the things that we're going to talk about is when the moon gets brighter, which we call waxing. When the moon gets dimmer, we call that waning. So you can remember wax on, wane off.
And there's also a new and a full moon. New moon is when we don't see illumination at all, and full moon is when we see total illumination.
So in this PowerPoint slide, it looks like we're looking at a full moon. So when we talk about the different, there's waxing and here's waning. You can see it get brighter and then dimmer.
And it's moving towards full, and now it's moving towards a new moon.
And one thing you do notice with this image is that you actually are always seeing the same side of the moon. That is kind of odd.
It is kind of weird, and it's moving. Obviously, it seems like it's moving around, but we never see the other side of the moon.
So that means the moon isn't rotating, or is it?
Well, no, it's got to be rotating a little bit.
So the way that this happens is something called synchronous rotation. And not only our moon does this, some of the planets actually do this, and moons of Jupiter do this synchronous rotation, which means that it takes 28.2 days, or about 1 month, for the moon to go around once, but it also revolves on its axis in 28.2 days.
Yeah, so the same revolution as rotation means the same side of the moon, or whatever body we're talking about, is going to be facing all the time.
So in the picture here you can see that the red dot is one side of the moon, the blue dot is the other side of the moon. The red side is always facing us. We've replaced that red and blue dot with Mr. Gates and myself. I'll be the moon, he is the Earth, and you can see that as we rotate, or as I revolve around Mr. Gates, I'm also doing a very slow rotation. One half of me is always lit up, and the other half of me is in darkness.
Yeah, just different sides of you are lit up at different times depending on your angle with regard to the light.
So now that we know that the moon does rotate, and we see different phases of the moon based on its illumination, let's figure out if we can determine what type of phase we're going to see and how we know when that moon is going to rise and set. Alright, so what we're going to do here is we're going to do a couple examples to show you what phase of the moon we can see and how much of the moon we can see. So let's say this is our setup. We've got the sun on the left side, we've got the Earth in the middle, and we've got the moon behind the Earth.
It looks like we're standing directly under the moon.
If I look out at the moon, I have the field of view of the moon. So if I was going to write down how much of the moon was illuminated, I'd say that the left side of the moon is illuminated and the right side of the moon is illuminated from my point of view in the northern hemisphere, I do have to say.
Well, to me, that means that the whole moon is illuminated.
So if the whole moon's illuminated, we call this a full moon. And that's why you can see it says 100% illumination. Now, one thing we want to know about a full moon is when does it come up? Because when we stand on Earth here, we rotate around this planet in how long?
24 hours-ish.
24 hours-ish. So to see the full moon directly overhead, or what time of day would we have to be outside?
Oh, wow. Well, noon is directly under the sunlight. We're on the opposite side of the Earth, so it's got to be midnight.
Midnight over here
is when the full moon is directly overhead.
Okay. So when does the full moon rise and set? Well, the way you can figure that out is kind of give yourself a dashed line through the planet here. Since we rotate around, we would actually start to see the moon when we hit this line. And what time would the full moon rise?
Well, that's a good question.
It's like sometime between noon and midnight.
Sure would be.
So the halfway point between noon and midnight is
6
p.m.
Mm-hmm.
So it's going to rise at 6 p.m. When's it going to set?
6 a.m.
All the way here. So when we spin away from the moon at 6 a.m., the full moon sets. So that was an easy one.
Yeah, let's do another.
Let's try a more difficult version. Alright, so now we've got this orientation. We've got the sun and the moon's not directly in front of Earth. It's kind of off to the side. It's not even at a 90-degree angle.
No, it's not.
So from my point of view, if I look out at the moon again, I've got two sides of the moon to look at. I've got the left side and I've got the right side.
And I see a tiny little bit of light on that left side, and it's dark on the right.
So most of the moon is dark on the right side and a little bit of light on the left side. So this would be what we call one of those crescent moons.
Yeah, crescents are when, well, they look like a crescent roll.
And to know if it's waxing or waning, we went from full moon, which was way over here, and the moon has traveled all the way to this point.
And it's getting darker.
So if the moon is getting darker, this would be a waning crescent. Now, we want to know, when does the waning crescent rise and set? So now we're going to draw that perpendicular line between you and the moon. And we want to figure out our rise and set times. Remember, noon is right here, and midnight's back here. So if we were going to spin around the Earth, when would we just see this waning crescent rise? Somewhere between, it looks like midnight and
looks around 3 a.m.
6 a.m. So 3 a.m. is the rise time, and 12 hours later, that waning crescent will set
at 3 p.m.
At 3 p.m. So that's how you can figure out the rise and set time. When we go outside and my kids ask me, why is the moon in the sky? It's daytime. Well, this moon rose at 3 a.m. and it's all the way there until 3 p.m.
As a matter of fact, it's directly over your head at 9.
There you go. Let's try one more. All right, last one here. Let's figure out when it's right overhead. That should be the very first thing. Remember, we've got midnight over here. We've got 6 p.m. right here, and noon right there.
Mm-hmm.
So, when is it directly overhead?
Well, it's got to be between 6 p.m. and midnight, which puts it around 9 p.m.
So about 9 p.m. it's directly overhead. And again, this is the left side of the moon, this is the right side of the moon.
Now, you kind of have to turn around to see that one, but yep, from your point of view, that's left and right. And this time I'm seeing light on the right-hand side, and it's mostly light on the right-hand side and a little bit of dark on the left.
So this would be not a crescent this time. This is bigger than a crescent. So we call this the gibbous phase. So gibbous phases are more than half illuminated moons. And now we have to know if this is waxing or waning. Well, on our last one we were at the waning crescent, and as we cross in this direction for the moon is almost to the full phase. So we know the moon is going to get brighter. So if things get brighter, you wax on.
Mm-hmm.
And we call this your waxing gibbous. Rise and set times.
Perpendicular line. What do we got?
Looks like we're rising about 3 p.m.
And we're setting about 3 a.m.
and sets at 3 a.m. Based on the Earth, Sun, Moon position, we see some of the moon illuminated, we see none of the moon illuminated, and it all depends on the orientation between these three bodies. In the northern hemisphere, the way that I remember it, the moon gets illuminated from the right side to the left side, and if I see more illumination on the right side, I know I'm in my waxing phase, and if I see a little bit of darkness on the right side of the moon, I know I'm
getting darker.
And that is our waning phase. So wax on, wane off, know how to figure out the phase of the moon based on these orientations.
Sounds good.
Sounds good. One more topic with the moon next time.